Now let's look at factors which affect equilibrium constants, and then let's calculate some equilibrium constants. Now in this case we're going to actually look at equilibrium being developed, being reached in various situations from a non-equilibrium state. So I want you to look at this data. You can see that it shows concentrations of each chemical, H2, and HI, in this reaction for each of 5 experiments. How do the initial concentrations for each chemical differ from those when equilibrium has been reached? How do the equilibrium concentrations compare with one another? And then calculate Kc for each of these experiments. Now remember that Kc only refers to the ratio of the concentrations once equilibrium's been reached. So it refers to the ratio for this data, not for this data, since the first concentrations, initial concentrations, do not refer to an equilibrium situation. And then say what you notice. Pause this video until you have done all of that. The initial concentrations of the reactants and products are not the same between the experiments. The final concentrations of products and reactants are also not the same between the experiments. Nevertheless, the Kc values with an experimental error are the same as one another. So that means that the ratio between the products and the reactants, adjusted to the powers of the coefficients of the balanced equation, is the same between the experiments. In other words, Kc is not affected by the initial concentrations of the reactants and products. Even though they differ between the experiments, still they give the same Kc value.